Hello everyone, this is our fifth video. Previously, we introduced the initialization of the controller, the initialization of C-Edge, and conducted experiments. Today, we hope to onboard our C-Edge through some template configurations and create a full mesh IPsec tunnel. The template we're talking about here is the device template. In the device template, there are some additional templates, such as the system template, OMP template, VPN, 0 and 5 on 12 templates, and interface templates, or device services templates. After creating such templates, we can reuse them and associate them with our C-Edge, especially in large-scale deployments, to improve the efficiency of our deployment. Next, we will switch to the experimental environment to implement the template configuration. This is our controller switching to the template menu. Let's create a template. In the entire experimental environment, we have two platforms. One is CAT8K and the other is CSR1K, so we use two sets of templates in parallel. When these templates need to be reused, we indicate it through the template name for reuse. The first one created is the CAT8K Edge template. Then, the template name, we give it a distinctive name. It's a CAT8K, specifically allocated for C8K, and the specific scenario and location we assign is DC. Since there are differences between DC1 and DC2, we use them as a distinction here. Of course, here we can also add C-Edge as the name. Next, we create a system template. There are many system templates. To not affect the system templates, we manually create a new template. This is the system template, and first we encounter the name. We also associate this name with C8K. That's it. And then there are some parameters. The first parameter is the site ID. Since the site ID is different, we need to assign it a variable. But we will fill it in during deployment. The system IP is also a variable. Understandable. Default is to keep it as default. Our time zone is specifically set for our DC's entire time zone. We can fix it. Set a fixed value with a static time zone setting. In the China region. Of course, you can also use variables. It's just that when we do it, we need to fill in the time zone variable again. Location is also a variable. For our baud rate, it's a fixed value. In addition, there are our latitude and longitude to facilitate in our overall global map to locate devices. Here it also remains a variable. That's all for the system template. We'll add an NTP template. I made an NTP template earlier, filled in an NTP server parameter. We'll directly use it here. After we explain the template, we'll create an OMP template, which is quite simple. Similarly, for OMP, I also created a custom template. It's just a copy. All default values are used. This is to facilitate future adjustments when implementing new features. To set, for instance, load balancing, we would adjust the ECMP parameters to achieve multi-link load balancing. Others remain default, like VPN 0 and VPN 512. Similarly, I also created a VPN 0. We don't use the default VPN 0, which contains interfaces. As we mentioned in our PPT, the interface is our physical interface VPN 0. We can think of it as a container. Using the name VPN 0 for DC1, we need to change the VPN 0 interface to active status. Next is the address. Here it's created in a tunneled form. Regarding the color, we need to give a color to the interface line. We think of it as a way to mark something in reality, like putting a label on an object with a specific color to make it easier for us to identify and recognize. Of course, it can also be referenced by access control lists. Here, it refers to the internet line. Regarding restrict, we will add a slide to explain what it means. In our actual environment, such as having internet and MPLS lines, if we enable restrict, it means only internet lines can create tunnels between each other, and tunnels are not allowed between internet and MPLS lines. This is the function of restrict check. We enable it to enforce this rule. This is our restrict check functionality. We turn it on. Here we have a recommendation. Since this is about VPN, we will have many VPN specific settings. Therefore, we name it VPN 0, and this VPN 0 is related to the internet. We give it such a name to make it easier for us when filling in parameters to easily identify this VPN 0. It makes it easier to identify this VPN 0. Alright, I've just finished creating the first VPN 0. Within this VPN 0, we'll add an interface. This name is just for ease of differentiation. It's for easy differentiation. We communicate through tunnels. Color needs to be globally assigned statically. It's an MPLS line, that's how we mark it. Also, we enable restrict check. Tunnels can be established between MPLS lines, but not across MPLS and internet lines with different colors. There's another VPN, 512. Since we configured the VPN manually, here we can choose not to use or go through a template to configure 512, keeping it at its default state. Next, the device's VPN in our topology shows that there are two service VPNs planned. One is PCI VPN, and the other is Corp VPN. Here, we will create two device VPNs. Let's add and create. We need to wait for the template name. This is for use with CAT8K, CAT8K's service VPN. If convenient, I'll directly define it as VPN10 to reduce the complexity of the name or its length. This also makes it easier to understand. VPN10, just copying it here, copied over. Next step, we add a physical interface inside this VPN. Currently, it's an Ethernet port. We create an Ethernet port template. This template is for use with C8K. We also give it a name related to C8K. Previously, it was VPN10. Who will this VPN10 be given to? Interface. For the interface setting, we abbreviate it and globally enable it. Then, the name. As mentioned earlier, it's VPN10. VPN10 can be saved and added. This way, we've added one VPN. Next, we'll add another VPN. Our operation is the same as before. We need to wait here. We'll create VPN20, okay? Copying it over. Globally, it's given the name 20, also global. Yes, named PCI. This is essentially a container. We add a physical port to this container, add an Ethernet port, create this Ethernet port. This is the Ethernet port's internet interface, abbreviated as INT. Globally enabled. The name is 20. The operation here needs to be a bit slow. Save. Add here. Our template is now created. Next, we will associate it with our C-Edge. DC Edge, we go to select templates to associate with the device. DC1 has dual devices. There are two devices, C-Edge 1 and C-Edge 2. We directly associate them here. fill in the actual parameters we need here. This will take a lot of time. I'll pause my video here for a moment. Now, I've taken some time to fill in the parameters we need into our variable area. We proceed to update. The status here is checked. Similarly, we do the same for the second device. It is symmetrical. Port 3, port 2, port 1. Site ID device 2. This is the longitude and latitude of Shanghai. The time zone is Shanghai. This is device 2. We have a table for address planning. Update completed. We click Next. In the next step, there will be a comparison of our configuration. Here, the corresponding configuration will be generated, and our configuration will be pushed to our device. Now the configuration is being generated. It will take some time. The process up to this point is complete with the template. The subsequent steps 3, 4, 5, and 6 are done in the same way. After class, I'll complete all the C edges to form a full mesh. In the next video, we'll check the previous results. This video ends here.